So in this video, we want to establish the second derivative test, which is a technique for identifying relative or local extrema of a function. So in the previous homework assignment, we developed the first derivative test. And the purpose of the first derivative test was to identify whether points on a graph were associated with either relative or local maximum values or relative or local minimum values. And what we did in that video is we looked at the sign change of the first derivative about a critical point. And we said, hey, if we switch from a positive to negative tangent line, we know that we have a relative maximum. If we switch from a negative to a positive tangent line values about a point, we know that we have a relative minimum. What we want to do in this video is establish the idea that we can use the second derivative more easily to identify when we have relative maxima and relative minima. And the idea is that simply this: if we have a relative maximum and we think about the geometry of the function at the location of a relative maximum, we want to identify that the graph of the function at a relative maximum is actually concave down. And if we have a relative minima, if we look at the graph of the function local or close to the location of that relative minimum, we want to notice that the graph of the function is concave up when we have a minimum. So when we have a maximum, the graph is concave down. When we have a minimum, the graph is concave up. And we just identified in our previous videos for this homework assignment how to identify when a graph is concave down. We said, hey, if the second derivative is less than 0, that tells us that the derivative is decreasing. In other words, the tangent line slopes are changing from positive to 0 to negative. So if the second derivative is negative, the graph is concave down. So if the graph is concave down, we have a maximum. So we can use the second derivative to identify when we have a maximum by looking at the second derivative and saying, hey, is it positive or negative at the critical value? So remember, our max and min occur at critical values. We find a critical value. The location of a relative or max min might be at the critical value, and then the max min, the local max min, is the function evaluated at that value. So the idea is if we plug in the critical value, which is at the peak of this concave down area, if f double prime evaluated at c is less than 0, if the second derivative is 0 at the location of the critical value we find, that tells us the graph is concave down. And if it's concave down, we have a maximum. Similarly, if we find a critical value c and we evaluate the function at c, and if f of c is a relative minimum, when we plug in the second derivative at c, because at a minimum the graph is concave up, we should get that the second derivative evaluated at the critical value is greater than 0, and we should be able to draw our conclusion from that. And so that's simply all the second derivative test is, taking advantage of the fact that the second derivative evaluated at your critical numbers is going to tell you the concavity of the graph. If it's concave down, we have a maximum. If it's concave up, we have a local minimum. So this is the second derivative test in summary. It says, hey, suppose you have a function and f prime of c is equal to 0. So in other words, we have a critical value of c which may correspond to a maximum or minimum. As long as the second derivative exists on an open interval containing c, dump the critical number you found into the second derivative. If it's greater than 0, you know the graph is concave up, which means you have a relative minimum, a low point on the graph. Or dump the critical number into the second derivative. If it's negative, if it's less than 0, then the graph is concave down, and you know that you have a relative maximum at that value of c. So the only thing you have to watch for is sometimes the second derivative won't be positive, nor will it be negative. So if you get a second derivative equaling 0, that just means you can't use the second derivative test. The test fails. You may have a maximum. You may have a minimum. You may have neither. You'll need to resort to the first derivative test from the previous homework assignment to determine whether you have a max or min value.